Okay, can you see my screen, Wagner?
Yes, sir.
Okay, good. So this is the paper, and I'm sure the first question you want us to look at is question number 1.
Yeah.
All right. So let's look at question number 1. It says a uniform lamina or ABC is a trapezium whose vertices can be represented by the coordinates in the XY plane. The coordinates of the vertices are or with coordinates 0, 0, A 15, 0, B with coordinates 9, 4, and C with coordinates 3, 4. So they say find the X coordinate of the center of mass of the lamina. Okay, so we've been given coordinates, all right. It might be the best if we can maybe make a sketch of what we have been given. So I have the plane here, the Cartesian plane XY, and for the shape, we have the point 0, 0, that's the point O. Then the point 15, 0, say it's here. So let's say this is 15, 0. Let's just say this is at 15. And there's another point B, 9, 4. So say here. And 3, 4. So let's say this is 4. So maybe like this. So the shape would look like this. So it's basically a trapezium if they have, as they have mentioned. So this point here is A. This point here is the point B with coordinates 9, 4. So the X coordinate here is 9. And the X coordinate here for the point C is 3. So this is basically what we are having. Okay, I hope that's all right.
Yeah.
All right, so they're saying here you should find the X coordinate of the center of mass of the lamina. The X coordinate of the center of mass of the lamina. So to find the center of mass of the lamina, we are going to consider the center of mass of each of these, because we are actually going to treat these as 3 different shapes: shape 1, shape 2, shape 3. So I've just separated them into 3 different laminas. So it's more like a combined lamina type of question. All right. For shape 1, the center of mass, I'll say that it is here, say. So this is G1. It has to be a third of the way from the right angled vertex, okay, right here. So a third of the way in both directions. So that's G1, and the center of mass of the rectangular laminar piece would be right at the geometrical center. So that's G2, and the center of mass of the third lamina, which again is a triangle, should be at a point that is 1/3 of the way in either directions from this point here, which you can see. So this is G3. Okay, so this is essentially what we have, and we are going to treat these as like I said, 3 combined. It's a 3 combined laminas, basically. Now we are going to use the fact that mass is proportional to area. So mass is proportional to area. We don't know what the mass of each of the lamina is, so we're going to make use of the area to represent to represent the mass. So M1 would be equivalent to the area of that first lamina. Okay, so I'm talking about this first one here. Okay, so its area, since it's a triangular lamina, is actually base times height over 2, right? So that's 3 times 4 over 2, which is 6. All right. Then M2 is the mass of the rectangular lamina, right at the middle, okay, which is length times width. So the length is 6. So basically 6 times 4. And that's 24. So that's going to be the mass. And then for M3 would be for the third lamina, which is again triangular. All right, which is this one here. Okay, so for its mass, we'll use the area base times height over 2. So we'll be saying that's this here is 6. So it's 6 times the height, 4 all over 2. And this gives us 12. So we have M1, M2, and M3. Now we'll also need big M, which is the sum total. Okay, the sum total of the masses, which essentially is 6 plus 24 plus 12, which would give us, what's that? 36 plus 6, 42, right? So M is 42. All right, so remember what we're looking for is the x coordinate of the center of mass of the lamina. All right, so we are going to take moments or consider our point of reference to be the origin. So we're going to do everything. We're going to take moments about or. So I'm going to say here, taking moments about moments about or, and considering that M of x bar, because x bar is the center of mass of the whole lamina, is equal to the sum of mi xi. Therefore, M, that's 42, times x bar, which is the x coordinate of the center of mass, should be equal to the sum of mixi. Let's start with M1. So M1 is 6. So M1 is 6 times the center of mass of the first triangle, this triangle with the center of mass G1, is at an x value that is 2 units from or. Remember, the x coordinate of the center of mass should be a third of the way from this point going to the left, okay, in this direction. So a third of the way means 1 part out of 3, which means from or it's 2 parts out of 3. So it's 2 units from or. That's the x value of the coordinates of G1 basically. I hope you understand that, do you?
Yes, sir.
Okay, so times 2. And that's going to be plus. Let's go to M2. M2 is 24. That's the mass. Times the distance from or of this point here. This distance from or is what we now want. And essentially, this is going to be from here to here. That's 3. And from here to here, that's going to be half of 6, okay, which is 3. So the total distance is 6 from or. That's the horizontal distance from or. So we're going to make use of 6. So it's basically 24 times 6. And it's going to be plus. Now we go to the third lamina, which is the triangle in yellow. That's M3. That's what we're going to need, which has mass of 12. So 12 times the distance, horizontal distance from or. So from or, this distance up to G, you understand? That's what we now want. So it's going to be up to here, it's 9, right? And plus a third of the full distance from 9 to 15. So it's essentially a third of 6, because from 9 to 15, it's 6. A third of 6 is 2. So this extra distance is 2. So 9 plus 2 is 11. So that's what we're going to make use of. We're going to make use of 11. That's the distance of G3, horizontal distance of G3 from or. Okay, it's 11 units. So 12 times 11. So I have 11 here. Okay, so that's 42 of x bar is equal to 12 plus. Okay, let's just do the whole calculation of this thing all at once. Okay, that's 12 plus 24 times 6 plus 12 times 11. And I'm getting 288. Are you getting the same?
Yes, sir.
Okay, then we divide both sides by 42. And when we do, we will get that x bar comes out as divided by 42, 48 over 7 as a decimal to 3SF, 6.857, 6.86, 6.86. So that would be the answer, okay? The x coordinate of the center of mass of the lamina. All right. Okay. So we're done with this question. I hope it's all good.
Yeah.